welcome to the Data Democracy. Presented by renowned O'Reilly author Ole Olesen-Bagneux. Empowered by Xenia. Make your data accessible and discoverable by anyone, anywhere, at any time.
Hi everybody, you're listening to the Data Democracy, and I'm your host, Ole Olesen-Bagneux, Chief Evangelist in Xenia and the author of the Enterprise Data Catalog published by O'Reilly. In this podcast, we explore what an enterprise data democracy is with knowledgeable guests. Today's guest is John Gorman. John is the co-founder and CEO of Semantium. Semantium is a language-first knowledge graph platform, and it's founded on the idea that business language is key to enterprise-level data and information management. The core value of Semantium is standard identity, classification, and language equivalence techniques that guarantee immediate benefits and long-range return of investment. My takeaways from my conversation with John. First, a data leader takeaway. Make sure you hire the correct people when it comes to understanding the link between language and data, because it's connected. Second, a data democracy takeaway. From structured to unstructured data, when we search for data and language, we are in one big semantic universe that can be connected to look at it all more holistically, and the knowledge graph is really key in that. And a third, a personal takeaway. John is the kind of consultant that is down to earth and thinks a lot. A real brain fryer. Okay, so here comes my conversation with John. Hi, John.
Hello. Ole, how are you?
I'm fine. And I'm happy to have you on, John. For the listeners of the podcast, can you share a little bit about your work experience, what you've done in your career, your background, so forth?
Sure. Yeah. So my data career kind of got out to a bit of a rocky start at the University of Calgary on a mainframe Honeywell machine. But I'll skip that part because it was kind of humbling, shall we say. So I worked in university analytics department that was having some trouble. When they first hired me, it was taking them 4 months to get their quarterly reports out, which is not great because they had to shuffle all kinds of different technologies and they were juggling things. But the president basically gave them a mandate that said we have to improve that. So my real sort of deep dive into data with the university was they had all of it's actually interesting because way back then they have the same issues we have now. They have different sources of data, from operational data to instructors to facilities, to all of those types of things, and they wanted some better metrics, and they wanted them, as I said, more quickly. So what we were doing was we were extracting data using SPSS. It's a statistical program because it was basically the only tool that we had at the time. This was really, really pre-analytics. There was no business intelligence platforms per se. So what we do is extract them, roll them into reports, and try to make sense of how the different sources of data played with each other. So that was my first experience. We decided that the best approach was to classify data coming out of those applications and trying to get some foundational structure underneath so we could understand, for example, how facility utilization related to student performance, that kind of thing. Mm-hmm. So we were very successful. Actually, we started to do get some process in place where we could do the extractions, make sense of the data, roll it into. At that time, we were just using Excel spreadsheets, mm-hmm. the usual suspects there. When we added financial information, it started the fog started to lift a little bit. And so we started to do longitudinal analysis on students from the time they applied to the university course, where the courses they selected, the programs they were in, how long we could retain those students. And then finally in that phase of my career, we started to add, as I mentioned, the cost of putting a student through a program and the offset revenue. So we did some, I think the upshot of that part of my career was we did the first activity-based costing longitudinal studies of students about how much it cost, how much revenue they brought in, retention, all those types of things. And we wound up identifying some dimensions of that analysis that came in handy sort of further along. And that was, again, the usual business intelligence things like, who was, which students took which courses at which campus, that kind of thing. And it started to sort of sow the seeds because we were doing the analysis first. It kind of started to sow the seeds that maybe there's a pattern here. So my next foray into data management was at the opposite end, was what they call unstructured content. And I worked for Documentum in the Bay Area in San Francisco.
Yeah.
So
Yeah.
one of the things there, it's content management at that time, and I think it's still the same architecture now. And that was, date myself here, 25 years ago. The architecture basically is a file store sitting on top of an Oracle database.
Yeah.
The challenge there was trying to find documents after they'd been put into the document management system, and for that we relied on metadata. So now I'm back to this sort of the structured data attaching to the documents. And that's where, when I was working in Houston for Documentum, that was kind of my big sort of epiphany moment, where I realized that the dimensions of the analytics were exactly the same dimensions that people wanted to search for documents. So they wanted to search for people documents, for example, resumes. They wanted to search for authors of documents. They wanted to search for operational documents like contracts, agreements, those types of things. And to your point in one of your articles, we realized that not only were the dimensions the same, but the search interface was too complex. So we wanted to make it very simple. And so one of the things that we started to understand was the language of every business that we touched was different, but the patterns of language were the same. So when I came back to Calgary and started doing some consulting work, the Documentum thing extended into the contract with the company in Texas. But when that was done in early 2000s, I started to work on those patterns. A big part of the BMC project was what I call the multiple of multiples. So they had multiple platforms, multiple targets for technology. They had multiple versions, multiple languages. I should have prefaced this a little bit. It was a technical documentation project. So this is all the documentation for all of their projects, online, printed, and different. So they had multiple formats, multiple languages, multiple platforms. And then they had this really tricky problem of tracking versions. So they not only had to track, BMC software does optimization for things like Oracle, Sybase, pretty much any technology you can imagine. But the technical documentation part was we also had to track versions of the product they were aiming at. So Oracle version 10, version 11, version 12, and all of the platforms, or all the software that sort of supported, and the technical documentation that supported that. So we had help topics like, inline help topics, online help documents, printed documents. They all had to be aligned. And so we wound up with this component kind of idea. And that, to the point about different verticals using different language, but the same patterns. So once you start to see the patterns developing, now things start to calm down. Now you've got some foundational things you can pin technical documentation to, because the rules are always the same. So out of that exercise was the Q6 classification was born. And it's an old idea. It goes all the way back to Rudyard Kipling. The who, what, when, where, why, and how of business.
Yeah.
And when I started working with it, I said, well, that's 6 categories is pretty bulky not bulky. The buckets are too big. So I split the buckets into 19, and I've got that on the web, and I post that quite a bit. But the 19 buckets are based on Rudyard Kipling's 6 on a Serving Man. So a simple idea, easy, really, really easy to teach. The business really likes it. The technology kind of took a while to catch up. So when knowledge graphs started to come on the scene, I finally had a way of expressing all of these different ways of mind mapping business language to metadata to instance data.
That's quite a story, and I want to try to pitch some of my questions that I prepared. I think also for the listeners that will be a great help, because that is a sense that you have been doing a lot of thinking while working, and I love that. I love that.
Yeah.
I do that myself. And I don't know. You said you dated yourself. Either you're younger than you believe, or I may be older than I think of. But
Yeah,
basically I can both remember SPSS and Documentum. So
there you
so
go. Yeah,
don't worry about it.
yeah.
So diving into knowledge graphs, you have this very special view of watching knowledge graphs. Basically, the question I prepared is, what are the benefits of a knowledge graph in terms of organizing and searching data? And that question is perhaps a little too broad in the sense
Mm.
you approach knowledge graphs, because you have this kind of reverse or loop view of knowledge graphs. Can you expand on that?
Yeah. So when the approach that we were developing, or I was developing and stuff, it turns out you have to get very, very granular about it. And when I first started using this technique for classification, they said we can't just classify documents, we can't just classify databases and that kind of thing. It all goes back to the very granular business language. So when I first started doing that, people said, well, no one's going to do that. It's way too granular. It's going to be like explosively. You're going to wind up with what's the phrase, Cartesian products. It's going to be huge and unmanageable, right?
Mm-hmm.
But when it turns out and we've done a lot of, like you say, we constantly sort of, and I say I mean sort of my partners and I, when we work on these kinds of models, um, the the real value takes place what we call upstream of data. And I think the democratization of data, the writing the book that you've been writing, and the posts that you make, this is right in your wheelhouse, because the classification and the connections that we use in graphs and the properties we use in graphs are all really, really highly constrained. So it doesn't
Mm-hmm.
matter which granular piece of information that you're looking at. It could be what you use the old canard about customer. Customer is just a word. If you talk to DBAs about customers, they immediately start thinking about tables and relationships and entity relationship diagrams and all that. So I think what knowledge graphs finally gave us was an ability to express these very, very highly granular concepts and metadata values and instance values in a way, first of all, that's visible, which I think is a
Yeah.
huge part of democratization of data.
Yeah,
It's
agreed.
yeah, it's understandable, because one of the things we found when I was working with the health authority here was the clinicians and the people that were on the ground really, really like to see the language of their business in a graph, because it's visual, right? It's navigable, it's searchable, all of that kind. So knowledge graphs really gave us another leg up. But the classification part that I was talking about allows you to do sort of business, like BI kind of operations on a knowledge graph, because it's faceted. And that's a term that I've used quite a bit. So the who, what, when, where, why are facets of information. That's 6 facets. If you imagine a cube, right? You can
Mm-hmm.
access a knowledge graph in Semantium from any angle you want. So if you're looking for a person, you can filter on persons, or you can filter in and filter out. So you can essentially slice and dice a knowledge graph.
Yeah.
And so all of the rules about observability and composability are all based on natural language. The really interesting part in the last year or so is this thing called, what is it, ChatGPT LLM sort of came on the scene.
I
And
haven't heard
it's
of that at all.
no, I didn't think so. Well, let me tell you a little bit about. So
Yeah.
one of the really interesting things about that, I was reading, and I think I posted this on LinkedIn. Stephen Wolfram, early on in the game, posted a really, really good article about no, um, how LLMs are structured, how they work. And then in the
Mm-hmm.
middle of the article, he sort of said, "What? But nobody knows why it works. It just seems to work. Like that's the very attractive part of it. But what it does for us is to say LLMs use tokens. Some of them not even words, like ing is a token, right? But when you think about a knowledge graph with facets and the power of the knowledge graph being visible and being extensible everywhere, when you think about putting the semantics of knowledge graphs on a solid foundation,
Mm-hmm.
now a lot of the challenges with LLMs start to disappear, because you can keep going back to the foundation and say, well, O'Gorman says customer is a role, full stop.
Mhm.
How you define customer in your particular organization, okay, it matters. It matters to the organization, obviously, but it has nothing to do with structure,
Mhm. Mhm.
right? It just give me a word, define it. Okay, we can pin that down and we can move on. And some people won't like the definition, but we're not there to have these huge bun fights about whether we get it exactly right. But the 19 categories work for every organization I've worked with. I've worked in 7 different verticals. I haven't found
Oh.
facet number 20 yet. So it has
Oh,
some
wow.
legs. And it also has, when we said, okay, what would happen if we took the principles of classification, those 19 buckets, and applied them to edges,
Mhm.
right? So the edges, our edges are all, there's only 6 of them that you can use to build for example, a conceptual model. And it's highly constrained. It basically says, this is what we need to know at a minimum. The complexity, if you want to build more complexity on the foundation or on the knowledge graph that's unique to your company, you go right ahead. But the rule is you have to tie everything back to the foundation. So it's saying like the symbol 1 is a number. It could be an identifier or whatever, but you have to tell me what it is first. And then you can use it in a sentence. It's all based on how language is formed, how language is used. It doesn't matter if you're speaking Danish or English. The patterns might be slightly the same in terms of syntax, but components, the elements, the really granular bits, you treat them all the same. So I just give you a quick example, Ola, of how we've used this, like the metaphors that come out of this.
Mhm.
The food supply chain, everything has a universal product code. So if you go into a
Mhm.
grocery store, everything has a code. And the codes were originally used to help customers get through the checkouts quicker. But then people began to realize that there's a slice and dice, there's business intelligence built into the codes that you can leverage for saying just-in-time delivery. There's all those downstream benefits. The UPC, the barcode itself is standardized to a certain extent. There's always exceptions. I think Europe uses a slightly different one than North America, but the principles are
Mm.
the same.
Yeah, yeah.
So to you, I really liked your article about making search for data as simple as possible. Just give me a search bar, one
Mhm.
search bar, type something in and see, and you can see finally sort of it's transparent. So our premise to your point, your question earlier was if you can use business language to connect to metadata and connect to instance data and then to data structures,
Mhm.
the business adoption on that is very, very quick because they say, well, I can type in anything. So yeah, go for it.
Yeah.
Type in a location, type in a person, type in anything. And then the knowledge graph will show you what that node, that very granular node, is connected to semantically. So, yeah. And then when you get down to data, so this is, think of it like I'm rambling a little bit, but hopefully I'm answering your question. Think of it like a ramp. So
Yeah.
the ramp to data democratization, I think, runs through a business glossary.
Mhm.
So
Agreed.
I might not know exactly what data I'm looking for, but I can go back to the business glossary and see what my concept that I'm looking for is connected to structurally. So
Exactly. Yeah.
that's it. Yeah.
Yeah, but because I've been looking at your diagrams, reading your articles, and
Hmm.
I see this enormous chain of not necessarily events, but causality from
Yeah.
language and concepts that are disambiguated into data and back to language again. And I
Yeah.
think I think that way of using technology, extracting stuff from unstructured data, applying it to data to get back to unstructured data. Can you share a bit more about that approach? I think it's very unique, and you really have to get your head around it to understand what's the idea here.
Yeah. So yeah, that's something we've been working on quite a bit because it's so easy to dive into the weeds on this stuff.
Yeah.
But basically, the unstructured part came with the Houston with the BMC engagement. So that's
Mhm.
where the nickel started to drop. Is that I can write a technical topic, right, that uses words that people would recognize in the field, in the discipline they're working in. Or typically what was happening was, as you say, the other way around. people would write a document without any kind of concern about the language that they're using. Technical writing is very disciplined. You have to be, for a whole bunch of different reasons I won't go into here. But so the part that whole loop part was that if the terms are already defined in a business glossary and we're creating topics or documents, right? We're using and reusing, to the FAIR principles, we're reusing the language that's in the glossary to create a document.
Mhm.
If we wanted to do it the other way, there's actually three ways, but if we want to do the other way, we have documents already written. If we deconstruct them and put those into a business glossary, right? Now we have, and we define those and or identify those or describe those. Now we're starting to build a glossary from unstructured documents. The third way, the third thing that's important is the end-to-end part is, if we have a business glossary and we're creating content, we can attach the business glossary, which are faceted, as metadata to the document. See, for
Mhm.
me, it's just how you use the language of the business. You can use it as to create content. You can use it as metadata values, but it's always consistent with the foundation of business language first. The thing is too is what I think what gets confusing a little bit is you have so-called legacy data, and
Mhm.
we treat that slightly differently because we don't have the luxury of trying to deconstruct everything, but we treat legacy data slightly differently. But if
Mhm.
you're doing a greenfield development application or whatever, the process is find out what the business language is, create a glossary, find out what they need to know about those entities, if you will, right? To use a
Mhm.
broadly sort of whatever. Find out what they want to know about those entities, and then store that, and then basically go out and talk about how you want to use that data for analytics. In the context of so-called unstructured content, I'm using air quotes there.
Mhm.
Structure Content has a structure. It's just that it's not very well organized. So in technical documentation, it has to be extremely well organized because they reuse topics, and the reason they reuse them is because for consistency of messaging. But the reason
Mhm.
they apply this discipline to the topics is because translation used to be very expensive. It's kind of like space when I was growing up. Um, Storage space was very expensive, so you typically took a lot of shortcuts, so you didn't have to store a lot of stuff. Those two
Yeah.
constraints are basically gone now. So the loops you're talking about can go in multiple directions, but it's all tied to the foundation of language has a certain patterns of syntax, language has certain patterns of classification, and language has, in order to reuse things, you have to identify them. So you had a question on your list about what does disambiguation mean?
Yeah.
I
Exactly.
did a
I
pre-
was
yeah, I did a
about to ask
presentation.
that.
Yeah, yeah. So disambiguation essentially means that rather than just using indexing, you actually take a term like manufacturing and split it apart. So manufacturing can be a noun, right? Can be said this is a manufacturing sector of a country like Denmark,
Mhm.
right? Manufacturing is also an activity. It's also a verb. So disambiguation means when Ole says manufacturing, we need to know foundationally whether he's referring to the noun or the verb, and we need to make both of those available in the glossary.
Yeah. Yeah. Yeah.
Because as we know, language, it doesn't matter which language you're speaking, Danish, Chinese, English, German, whatever, um, those translations depend on that separation of those two words um, downstream. And it's also really interesting too because when you're having conversations, you say, "Well, are you referring to manufacturing as a noun or a verb?" And once you do that, everything else goes away. There's better examples in manufacturing because some words like table, for example,
Mhm.
like table, you can define or describe as a four-legged thing that has a platform that holds things up off the floor. Yeah, that's fine. But if you're in the context with a DBA and saying table, that's a whole different meaning.
Yeah.
But when we have these conversations, and and I've had them on LinkedIn recently, where you're talking back and forth, and you're arguing different points, and then you go, "Oh, you're not talking about table in the same sense I'm talking about it." Oh,
Yeah. Yeah.
okay, that makes everything much more understandable. So, for
Yeah,
example, in
definitely.
a search, in Semantium search, and to your point about finding data, you can enter a term like table, and it'll give you 5 or 6 different options and say, pick which one of these 5 options you want to explore more, and then the other 4 options disappear,
Yeah.
which is kind of cool because now you're on a knowledge graph track that says everything I'm going to talk about, everything I'm going to find in this track is related to a DBA table, not a restaurant table. Flight is another good one. Like there's lots of conversations about how different people in an airline industry define the word flight. Well,
Oh
if they
yeah.
all have legitimate uses, then why not add them to the glossary? Say, well, flight is to an engineer means the time that the wheels leave the ground. Flight to a customer means an entirely different thing. So hey, so let's
I
disambiguate them and say, okay, so and it sounds like overkill, but tokens do exactly the same thing in an LLM, but they do it in a much different way. It's embeddings do that.
Yeah, no. To me, this is not overkill at all. I think I have two questions. One that I prepared, and then one that I just feel like asking, like just like that, because throughout my career, I've had this constant clash with master data,
Mm,
and it's not that I don't respect master data. I understand what master data does, but the way you're describing the multitude, the semantical multitude of meanings for every single word out there,
mhm.
flight, table, manufacturing, have you had these very have you encountered these very categorical pockets of resistance to what you do from a master data perspective, or have you always like manage to get those people on your team, because basically they're doing something very, very important. It's
Yep.
not that I am challenging master data at all, but
Mhm.
it's just you have to really scope it, because master data creeps out of its necessary
Yeah.
task.
Yeah, I think in our contract we agreed not to before this interview not to talk about master data. So, but I will reluctant. No, I'm just kidding. So
Okay.
one of the I think one of the things that there's a few things to unpack there, but one of the things I think data management folks do is they slice things into different buckets that
Mhm.
sometimes the business doesn't understand, right?
Yeah.
So master data, reference data, transactional data, they're going, why? Like I just doing my job. Like you say, I have a job to do. In terms of, answer your question about resistance, absolutely. And when I first started doing this kind of stuff, it was basically the stick approach. We have to have one definition for flight, full stop. We're not doing any other. So everybody in a room, we're going to get the engineers to agree with the consumers that what the word flight means. And as you
It's
might
impossible.
imagine, yeah, no, I think um, if you're a cynical person, a consultant would love that kind of gig. You spend hours
Yeah.
and weeks and months and say, we still haven't figured it out, but I'm billing you $110 an hour. So
Yeah, exactly. Yeah, exactly.
what came out of that was all the bruises, cuts and bruises and stuff came out of that one as well. Is there a way that we can accommodate those differences? Absolutely. And they typically happen with concepts more than typical definition of master. Like if person data, customer data, things that you can make real, like Eiffel Tower is a thing. We might be able to put that in a master, or say BMC Software Inc. is a needs to be mastered. Scott Taylor has a great um, demonstration about how mastering data gets really complicated. Like
Hmm.
7-Eleven, he's got a great graphic that shows something like 36 different spellings of that word, so it needs to be mastered. But here's the thing. So there's a couple of things. One is that master data is available on the web. Like you can see what 7-Eleven prefers their store to be called, their company to be called, just use that. But when you have variations of a master data element, like 7-Eleven or BMC software, is it BMC software, comma Inc. period, that computers have all kinds of trouble with. People don't, because BMC Inc., right? BMC software, it's all the same. So what Semantium does, and this came from the need to connect like codes and identifiers. What we do is we create a semantic equivalence. So in a graph view, you would have we don't typically don't use preferred, but we have, let's say a company agrees that BMC Software Inc. is the one we got on the net from Standard & Poor's. And then we have all of these variations around it. So we create semantic equivalents to the variants and use the one in the center as the master. Simple.
Yeah.
And I mean, address data is another master data category bucket, right? In my day, it was my day. I didn't think I'd ever use that phrase, but anyway, it's you had to do some hard wiring and hard mapping and things like that. Now you can just you can type an address into Google and it'll tell you exactly if that address exists, and it'll give you the canonical the canonical spelling exactly right, and you use that. Yeah, so there's a couple of things. I totally agree with you on the master side because it does get a little creepy. Use a Halloween metaphor, but also there's no need to spend a ton of time trying to figure out how to rectify all of those different understandings or spellings of it. You can just create, and again, it's all about accessibility. It's all about transparency. So if BMC software or 7-Eleven is spelled a bunch of different ways, and you want your users to see that, you can do that because they all connect to the hub of that. A lot of our stuff is hub and spoke, even really, really tiny ones. So the 7-Eleven, the right spelling of that phrase or BMC software sits in the middle, and everything is equivalent to it. Every other variant of that is equivalent.
Thank you for being a supporter here. I've met quite a lot of resistance, but I've also met master data people where we really found common ground, right? And it's definitely possible to get there, but both sides need to soften up a bit. Yeah, I've been very anti master data in my days. Anyway, I want to ask you the final question here. In a Semantium perspective, to what degree is there a difference between data and language at large? If you can give that kind of answer, if it's possible.
Right. The first thing that came to mind when I read that question was, and I heard it again today, was structure. So our premise is that you can't create data without language. It's a prerequisite. And the feedback, and you talk about pushback and resistance that I get was like, well, you don't understand. What about IoT stuff? That's data, right? What about? And I said, well, okay, but if you're using human symbols to communicate with a computer, which translates everything into ones and zeros, language first. So I think the relationship between language and data, there is a difference, but it's mostly in structural complexity and structural. Maybe that's the wrong word to use, Ole, but yeah, it's if language is made granular enough in the business, which is something that business actually appreciates, because business users don't necessarily want to start with data because it fries their minds. But when you can show them how a concept like product or a concept like customer or a product like flight, for example, connects to metadata, because you can translate metadata too, right? Like if somebody is using FLT-num and some other application is using flight-ID or flight, or flight-CODE, those two are equivalent. So the language part of it is the feedstock. It's the upstream raw materials that makes data. So I'll leave you with a metaphor. There's only 90 usable elements in the periodic table. There's an infinite number of combinations of those some of which we haven't found yet, that can create anything in the known universe, because that's how chemistry works with products, for example. But there are rules about how those things are combined. Like you can't just take a molecule of magnesium and connect it to a molecule of, I don't know, selenium. They don't work together. So language is the raw materials, the elemental bits. Data is the assemblies, the components, the molecules, if you will. And our premise is that whenever you use a molecule, whenever you use an element, its identity and class and equivalence has to track all the way out to molecules and back again, to your point earlier about content.
John, I thank you for your for your deep answers. You definitely also managed to fry my brain a little bit, but I loved it. And I look forward to exchange views on LinkedIn and hopefully also in the physical world in the future. Thank you,
Right.
John, for being on.
Thank you very much for having me. It's been a pleasure. Thank you.